All right, so here's our review for work. This is actually conservation of energy stuff, or all the energy that we're talking about so far. I need to give you a few formulas. I actually gave them to you on the sheet itself, but hey, why not? Potential energy, that's mgh. That's an object's weight in newtons times its height, times the height it's been lifted up, or the distance. Kinetic energy, 1/2 mv squared. These are things we've already gone through a number of times. I hope you remember that stuff, but if not, I guess that's the way it goes. You probably didn't want to learn it in the first place, so you ignored it, and you probably copied somebody else's answer or something like that. I implore you, please try and remember this stuff. You're going to be taking an exam, but I can't stand over your shoulder because you're at home and I'm at home. And there we go. I'm going to just stop talking about it now. And then we talk about conservation of energy. Conservation of energy states that no energy can be gained or destroyed within a closed system. So what you start with is what you end with. So the sum of all your energies is in the beginning is equal to the sum of all your energies at the end. So you lose some energy due to friction. Sometimes we talk about this. Sometimes we talk about the work put into a system which creates your potential energy. And so I did type that on the sheet that you had, and I highlighted it for you. But mostly we're talking about potential energy, and it's before something's moving, or kinetic energy because something is already moving. And then we do all this work with it. And that's really all there is to it. I'm going to look at the problems and see if there's anything, other than what I already typed all over the worksheet. Yeah, there's really nothing else. I did have a question yesterday. Somebody was asking me about joules and watts. Completely different units, but you're not used to work being, kilogram, Newton meters, and you're not used to being Newton meters per second with watts. And, so we call Newton meter is the same as a joule because the work put into something is the same as adding potential energy to it. So we can call those joules. And when we divide it by seconds, those joules become watts. And that's really the big idea of the question yesterday. So I thank the person who asked that question because it was a very good question. It's been so long since we've worked with those units that, at least we're getting back into it. So energy. And we just sort of look at the units that we have there, right? So we have mass times gravity, which is kilogram meters a second squared times height. So it's another meter. So it's kilogram meter squared second squared, or Newton meters. Newton meters, which is a joule, right? So we don't write in Newton meters, we call it a joule. The work we put in, sometimes we can call it Newton meters. And then we look at the wonderful units here, and they look exactly the same, basically, right? So we look at our mass, and there's kilogram. And then meters a second, that's our velocity, but we square it, so it's meters squared over second squared. So it has the same unit, whether it's kinetic or potential. And so if you're working it out and you have your units, you'll see that they look identical when all written out. And remember, we started changing these things because we started stacking units, and too many, m squareds and s squareds and all the other stuff that goes with it. So we started changing that stuff. I'm not going to do any math for you. I'm going to let you do the math on these pages. Very, very simple. Some answers are identical. I just want you to understand the situation. I'll give you another worksheet, and you're actually going to find the kinetic and potential energies at certain points on a roller coaster most likely.